I am intrigued by the statement that our biological endowment does not give us the ability to grow wings, and the observation that it does give us the ability through a lengthy process of bootstrapping to build a machine that has wings.
That has?
A machine that has wings, an airplane.
Oh,
we build tools with which we build more complex tools, with which we build yet more complex tools that eventually allow us to build an airplane. And I'm left wondering how much of that process applies in the cognitive domain. To what extent may we be able to build machines that help us conceive new machines, and eventually understand things that as biological organisms alone we cannot understand?
What you're describing is in fact what interested early modern science. So Leonardo da Vinci conceived of an airplane. Couldn't build it at that time, but he could conceive of it. The thinking of the early modern revolution, Galileo up through Newton, which is the foundations of modern science, was based on what was called the mechanical philosophy, the idea that the world is a machine, the universe is a machine, the kind of thing that could be constructed by a master craftsman, and in fact was constructed by the ultimately skilled master craftsman. That was what that was the fundamental idea of the modern scientific revolution. So Galileo, for example, argued that if you can't construct a machine, and machine means just what you're describing, gears, levers, things pushing and pulling each other and so on. If you can't construct a machine to explain some natural phenomenon, you failed. And in fact, he felt at the end of his life that his scientific career was a failure because he was not able to construct a machine to account for the tides or the motion of the heavenly bodies and so on. And that goes right up to Newton. Newton's great discovery was the world isn't a machine. It's not a machine. It has what were called occult elements, forces like action at a distance or repulsion at a distance. And that's not part, machines can't do that. So the amazing discovery is the world simply isn't a machine. Newton, as I mentioned, regarded this as a complete absurdity. He never accepted it, spent the rest of his life trying to disprove it. Other great scientists of the day regarded it as ridiculous, Leibniz, Huygens, and so on. And for a long time afterwards, the scientists did try to show somehow that the mechanical science could account for the world. Ultimately, Newton's proofs just became scientific common sense. People gave up the enterprise. And science changed radically from trying to show that the world is intelligible to us, which was given up, to trying to show that we can construct theories that are intelligible to us. And that's something quite different. It's a radical change in the nature of science that took place. It was understood by Locke and Hume. That's why Hume, in his, if you read his history of England, where he has a chapter on Newton, the greatest genius who ever appeared, he points out that his great achievement was to lift the veil from some of the mysteries of nature, but to show that there are other mysteries which we will never penetrate, which turns out to be correct. Science has just changed its objectives. It's lowered them. And when you come to your question, we just don't know. There's every reason to suppose, I think, that cognitive capacities are like all other capacities. They're biological capacities. And it's just part of the logic of a biological capacity that if it has any scope at all, it's going to have limits. The reason it has scope is because of some of its intrinsic properties. So we have intrinsic genetic properties that determine that from the nutrition of the cell, of the embryo, we end up with a mammalian visual system. But by that same token, these same properties tell us that no matter what the nutrition of the embryo, we're not going to get an insect visual system. Scope and limits are logically related. And that actually was Peirce's insight that I quoted about abductive principles. He's often misunderstood. So in modern contemporary philosophy, Peirce's argument, philosophers among you will know, is often interpreted as what's called inference to the best explanation. But that's not what he said at all. What he discussed was the idea, which I think is plausible, that you can't learn or discover anything unless there's some initial limitation of the hypothesis space. It has to somehow be limited to particular hypotheses. And in support of this, he discussed the history of science, and he points out that if you look at scientific revolutions, quite typically, when particular circumstances exist, a particular level of understanding, particular problems being formulated, there are often many people who come to pretty much the same conclusion. Some of them get there first and we attribute it to them, but others are pretty near. And the reason he argued is that these conditions are somehow putting in operation our internal abductive principles. He didn't know what they were, and we don't know what they are, that limit the hypothesis space. So you explore certain hypotheses and not an infinite number of others that are consistent with the evidence. And the same has to be true of learning. Just couldn't get off the ground unless the child's hypothesis space is highly limited. And in fact, we're coming to understand very limited. So that gets to your question. How far can our abductive principles reach?
And
Who knows?
could a cyborg reach farther?